Hello, this is Captain Chaudhari. In my series of videos on marine astronomical navigation, today I'm going to talk about the equation of time. Our social activities are decided by sun. So it is very important to have a time system which is based on sun eventually. But sun, having said that sun is so important in our day-to-day activities, sun has got certain drawbacks. Sun moves on ecliptic, right? And the problem is sun moves on ecliptic at varying speed. But we know that sun moves on ecliptic, but the time is maintained or time is measured on equinoctial or the celestial pole. So this is the time axis and this is the time base movement axis. Sun is our time base, and that sun, the time base, moves on ecliptic a different direction. What we basically want is this true sun which is moving on the ecliptic at varying speed. If we have a mean sun which moves on equinoctial at uniform speed. Only thing is, suppose you have true sun here and mean sun here, and while measuring their meridians or difference in their meridian, which is called equation of time, if we are somehow aware about this equation of time, we would say, okay, here is the position of true sun, but we know the equation of time, so we also indirectly know the position of mean sun, from which the time can be decided for any territory or the global time itself, right? So what is important is we imagine a body, imaginary body, that is the mean sun, which moves on equinoctial at a uniform speed. The total time taken by mean sun to go around the equinoctial is same as the total time taken by the true sun to go around the ecliptic, and mean sun moves at uniform speed. So then we will not have problem. We will not have problem so long as we know what is at any given time, what is the difference in their meridian as measured at the pole, and that difference will be called equation of time. So by observing the true sun in the sky, we are able to find out what is the LHA of true sun, or we are able to find out what is local apparent time. And when we apply equation of time to local apparent time, we are able to find out LMT. And if I have longitude of the place known, I know GMT. And if I know GMT, I know what are the times kept in different countries. Equation of time is made up of two components. One is the component due eccentricity of Earth's orbit, and other one is obliquity of ecliptic. You know that sun moves on ecliptic in its annual journey. Is the sun moving uniformly on the ecliptic? Let us try to analyze that. In the Kepler's second law, we had said that the radius vector sweeps equal area in equal time. That means sun moves rather faster here near perihelion and moves slow during aphelion. That means the true sun, as it appears on the ecliptic, should also be moving fast and slow respectively. The relative diagram would be the drawing of ecliptic, which is the movement of sun. Suppose we want to track the true sun as it moves on the ecliptic. If this date is perihelion, the true sun would be moving fastest. And if this is aphelion position, the speed of true sun will be slowest. Right. So suppose we say that we imagine a body called dynamic mean sun. Suppose we imagine a body called dynamic mean sun, and we start the movement of dynamic mean sun and true sun together on the ecliptic, the conditions for movement of dynamic mean sun is the total time taken by the true sun to complete one revolution. Dynamic sun will also take the same time, but dynamic sun will move uniformly. So if the dynamic sun is moving uniformly and true sun here is the fastest, very soon what will happen is dynamic sun will be overtaken by true sun, right? But what happens is, as the true sun approaches the aphelion, the speed becomes slower and slower, and because in this phase the speed of true sun is reducing and dynamic mean sun is moving at uniform speed, once again we'll have true sun and dynamic mean suns together. And once again what will happen is, over here the dynamic mean sun will be seen moving faster because the true sun is moving very slow, and again the gap will be created between them. But by the time the suns reach perihelion, dynamic mean sun moves at steady speed and true sun starts moving faster and overtakes at perihelion. So according to this assumption that at perihelion and at aphelion the two suns are together, we can say that the component of time difference, or technically we call it equation of time, becomes zero twice in 1 year. So this shows one of the drawbacks of the sun. Sun does not move uniformly on ecliptic, and this is because of, the explanation is given by the second law of Kepler, that the Earth in its orbit, Earth in our orbit does not move uniformly. So if we say that this discrepancy of the time that is developed between a uniformly moving sun and the actual sun, if we can call it the component of equation of time due to eccentricity of the Earth's orbit, we say that this particular component, which is due to the eccentricity of the Earth's orbit, basically becomes zero twice in a year. Now obliquity of ecliptic. To understand obliquity of ecliptic, let us draw the usual diagram. The equinoctial and ecliptic, this is first point of Aries, and this angle is called obliquity of ecliptic. It is represented by omega. Now to understand this component, which is because of the obliquity of ecliptic, because the sun moves on ecliptic and the time because of the sun is measured along the equinoctial, what kind of problem can arise? So let us say that there are two suns over here. Once again, they start together, both move at uniform speed, but one moves on ecliptic, other moves on the equinoctial. So naturally after 3 months both the suns are going to reach the extremity. Now when both the suns, they started their journey, the angle between their meridians was 0, and when both of them they reach the extremity, once again their meridians are same and the angle here is 0 once again. But suppose we talk about the journey after 1.5 months approximately, you will find that the meridian passing through one sun is different than the meridian passing through another sun. So this component which is developed would not have developed if both these great circles were in the same plane. This component is developed because of this obliquity, and this component which is developed because of obliquity of ecliptic, as you can see, the two suns are together here, they will be together here, they will be together at Libra, and they will be together here. This component becomes 0 4 times in a year. So here, in a way, we are comparing the mean sun and dynamic mean sun, and earlier we compared the dynamic mean sun with the true sun, right? Once again, In the previous diagram, that is when we were talking about component due to eccentricity, we compared true sun and dynamic mean sun. And here in this diagram, we compared dynamic mean sun with mean sun. So this dynamic mean sun is just for this purpose, that there is a common observer in these two situations, and we can get rid of this dynamic mean sun, and therefore when we combine the two components, say E1 and E2, this will give the resultant equation of time. So this component, the component due to eccentricity became 0 2 times in a year. Component due to obliquity of ecliptic became 0 4 times in a year. If we combine these two components, the total equation of time becomes 4 times 0 in a year.